Okay, all right, so here's what we're doing today. Let's go through a couple of your homework problems, and that way you get kind of a sense for how to attempt them, so I'm not just leaving you hanging, because I know I just gave you homework, and there's some problems that were very different than anything I've covered. I'm going to go to like the first one, so if you have your homework, you can take it out. I want to look at a problem like 14 or 15 or 16 or 17, because those problems, they ask you to solve a limit, right? And your instinct is to go through and solve it by normal means, right? Which is fun, right? On that first one on 14, this is what they're giving you. They give you something like this. I think this is cubed. And then there's a 27, and then there's an h. You could go through this problem and do it by its normal means. You could simplify it. You could, FOIL that out. If you FOIL this thing out, it's like 1h cubed. Or I should say a negative h cubed, and there's a 27 and a 27h squared. There's a bunch of numbers, and you have the minus 27. You have it over h, and you can cancel out terms. You can plug in. You can divide everything by h and simplify, and eventually you can get that your answer ends up being like a 27. Right? If you did it all correct and you got everything out, right? You could do it that way by the traditional differential quotient means. Right, you can simplify it, divide h's, and it ends up, if you plugged in h of 0 at the very end after you simplify everything, that's your answer. Does that make sense? You could do 14 like that. But when you go to 15 or 16, sometimes the problem is you can't do it, right? With the math they give you, we don't have the skill set where, let me give you an example, I'm going to do the cosine one, right? So cosine of h minus 1 all over h, right? And the limit as h approaches 0. Well, here's the idea. I can't just plug in 0, right? I can't even divide h's off. I can't simplify it. So what I want you to do on this problem, I think this is 15, right? What I want you to do, and this is the hint I gave the sub, hopefully he related across, I don't know if he did, that's why I want to cover it, is that you could approach this problem by looking at the left and right side. Right? Because this is a limit, right? Limits mean as you look at a curve like the drawing, and you approach from the right and left side, are they approaching the same y number? And that's what I want to know. So here's what you could do. What's the number I'm trying to approach?
0.
0. So here's what you do. You set up a table. That's a terrible blue. So you take your number and assume 0 is right here, right? That's 0. That's where I want to approach. But I go to the right and left of it, and I go a few numbers. So let's say next to 0 on the right side, I do something like this. And then I go 0.01, 0.1. I'm getting further and further away from 0. And as I go this way, this is the negative side, negative 0.001, negative 0.01, negative 0.1. And what you're doing is you're getting closer and closer to 0 from the right and left side. And what you do is you plug these numbers in for h's. So I'll plug this number in for h's, type it in my calculator, hit enter, and this is the function value. So this would be whatever number spits out in the calculator. Okay? Let's say that ends up being 0.9999999, right? And this ends up being 0.9999999. And 0.9999999. And then on the other side, these are 1.00001, 1.001, 1.01, right? What number am I roughly approaching?
1.
1. That's your answer. You can do that. That's those first 4, and that's not the answer, by the way. I'm literally making those numbers up. But you plug in numbers that are really close, 2 or 3, kind of see where it's going. That's your answer. But you got to go as close as possible. That's why I'm using a lot of decimals. More zeros, the better.
Yeah.
Does that make sense? What you want to do? Okay. That's what I recommended. I don't know if the sub relayed that information across efficiently. I have no idea. But that's how I would attempt 14 through 17.
He told us to look at the table on page 80.
Okay. He was probably reading through the book trying to figure out. I literally had that drawn on the bottom. I said just tell him to plug in x's that are close. So if he told you that, that's how you do this. Make sense? Okay, now, the next type of problem they give you a drawing, like a graph, Okay, I think this is the next problem. Something like this. Like this, like A, B, C, D, E, and F, or something like that. And it wants to know, like, where certain values could be. Like, for instance, like, where would slope be 0?
C.
At letter C. Like, that's what they want to know. C is where slope is 0. It's right here. But they give you a bunch of others. Like, where would the slope be -1? Well, maybe a letter D or a letter E. Just kind of whatever one looks like it's 1 to 1. So I would say letter D in that case. That's where slope looks negative. It's going down to the right. This one looks like it's maybe more, it's horizontal, so it's maybe getting closer to 0. On the others, like where these are positives. And you're kind of comparing and trying to figure out which slope fits with which letter. Does that make sense? Like positive and negative slope? Negative slope goes down. So how I do this, and you're actually seeing me do it. When I look at these dots, I look at what does the slope line look like right there. Like I'm drawing like an imaginary slope that would perfectly hit that dot and not touch the curve. That's called a tangent line. Okay? Just barely scrapes the surface. And what would that slope look like? Well, that's a negative slope. It's going down to the right. Does that make sense how I'm approaching that problem? Sometimes they ask you, like, tell me the slopes in order. Like, what's the biggest slope you have there? What's the smallest slope? Well, that'd be the negative numbers. Right? These would be the smallest slopes. This is 0. This is probably the biggest slope because it's probably 1. This is probably getting more like half. This is 0. This is maybe half or 1. So like you can like kind of figure out where the slopes are depending on how steep it is. All right, questions at all about slope? And then the last 4, 25 through 28, that general area, those problems they want you to do this thing again, where you're doing them this way. Where you're doing the differential quotient, you can simplify the problems down and just tell me what the number turns out to be after you simplify it. If you can't simplify, you do it by the chart there. Okay, does that make sense what we're doing? Yes.
Is it okay for those last problems if we just did that way?
The chart? Yeah, do the chart. Maybe you just didn't understand how it works. Do the chart. You have free reign to do both. Okay, does that make sense now? Okay, we're done for today. That's all I want to do. Again, my intentions are not to seem like I'm not empathetic with this situation today. Just want to give you a kind of normal day. If you need to take a step out, take a breather, go talk to somebody right now, because it can hit you at different times. Do that. You don't need to tell me. Just go. I respect that. So, but yeah, the rest of the time is yours. So, there you go. Let me give you a pass. Just go grab a yellow piece of paper off my desk.